Hello, right, this one's maps and scales. We've come across scales before when we've had to draw, for example, the plans and elevations on a grid, and we've generally said that 1 square equals 1 centimetre, or 1 to 1 is like that, like a ratio, 1 to 1, and there's a scale. Of course, when we get to maps and scales, it obviously can't be 1 to 1 because the map has got to be much smaller than the area it represents. So it's going to be a different amount. So let's look at something like this. Yeah. So here's a boat. Yeah. And the scale of the boat is, say, 1 to 50, just written out like this. And what this means is the real boat is 50 times bigger than the uh, model or drawing. Yeah. For every one on the model or drawing, the real thing is 50 times bigger. So if we get whether I can just move that down a little bit. Oh, hang on. There. Let's move that down a little bit so that I get there. So we might get a question that here's a drawing of a boat with a scale 1 to 50, and we need to find out how big the actual boat is. So you get your ruler, there's the ruler, and we're going to go 1, 2, 3, 4, and from there to there, it looks as though it's about 3.5 centimeters long on the drawing. Now, if we want to find out how big the boat is, this represents the 3.5 centimeters, the one, and we want to find out what 50 times that is. So we just multiply that number by, not by 10, multiply that by 50, which is 150, 175, 175 centimeters, yeah, which converted is 1.75 meters long. So we've got, I know it's a tiny little boat, but it's just a representation. So the scale is 1 to 50. Maybe the scale should have been a bit more, so we've got a bigger boat. But yeah, it's 1.75 meters long in reality. Must be one of those, no, yeah, 5 feet long. That'd be all right. You could get maybe 2 people in there. Tiny little boat that you go around the lake on. So that's how to work out a scale. Now we can go the other way around. Uh, if you measure a field, yeah, and the field is 40 meters long, and you want to draw a plan, and your plan is, I don't know, 1 to 1 to 400, yeah, 1 to 400. So how long, or yeah, how long is the field how long is the field on your plan? So what we need to do is now this side is the represents that one. So our plan must be 400 times smaller than this. So we're going to go 40 divided by 400, which is equal to 0.1 of a meter, which equals 10 centimeters. So the length of the field on your plan will be 10 centimeters long, and that will represent a field using a scale of 1 to 400 that is 40 meters long. So there's sort of going backwards and forwards between scales. There is another kind of scale that you can get. So you can have town A and town B, yeah, and you can have something like this in the corner. You might have seen this on the map. That represents 5 kilometers, and you need to know how far it is between town A and town B. So you get your ruler here, and you go 1, 2, 3. So you'd say that that was 3 centimeters. So 5 kilometers equals 3 centimeters. Well, it didn't equal, the scale is 5 kilometers to 3 centimeters. Now, all you would do then is measure how long that would be, 3, 6, 9, 12, 15. And so you measured that at 15 centimeters. Yeah. Now, you take these two numbers here and go 15 divided by 3 is 5. So this is now 5 lots of 3 centimeters. So you need 5 lots of 5 kilometers, which would equal 25 kilometers. This is almost like, you could put your thumb on there and just go do, 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 do. So 3 centimeters between here and here, 15 between here and here. Well, this is 5 times as much as that. So you just multiply the kilometers. So the actual distance between town A and B will be 25 kilometers. Okay. Let's have here's an architect's plan of a room, and the scale is 1 to 150. Yeah, you measure the room, and it measures 3.7 centimeters. So how big, how wide is the room? So we've got 1 to 150. So the measurement here, 3.7 times 150, will be the width of the room. So let's do that on the calculator. 3.7 times 150 is 555 centimeters. Divide that by 100 to change it to meters. 5.55 meters is the length of the room. Right, now let's go back to those two towns. So there's town A and there's town B. We'll say that the distance, there's awful lot of different ways that these maps and scales can be presented to you. The distance between A and B is, this time it'd be 10 kilometers, yeah? So the distance between those is 10 kilometers, and you're going to need to work out the scale. Work out scale. So you'd get your ruler along here. There's my ruler, and you go 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters. So our scale is 8 centimeters to 10 kilometers. Now this is where it gets tricky, because you might see a scale where you don't have centimeters and kilometers together. So what we need to do is we need to change the kilometers into centimeters so that they match. When both sides match, then we can lose the units. For example, if we've got 1 centimeter equals 1 meter, we could have 1 centimeter on the map didn't equal is 100 centimeters. So we can just lose the units and we go 1 to 100, because that is 100 times bigger than that. Yeah. So what we're going to do is we're going to try and carefully lose the units. So first of all, I'm going to leave that as 8 centimeters, and I'm going to change that into centimeters. Now, I'm not going to do it all in one go. I'm going to change that into meters by multiplying it by 1,000. So I get 1, 2, 3 meters. Yeah. Then I'm going to go back to the blue. 8 centimeters. Then I'm going to change that into centimeters by multiplying it by 100, which will be another 2 noughts on the end. Now I can lose the units because they're both the same. So I've got 8 to, how many noughts are there? That. So that's scale, but you wouldn't normally see a scale like this, because you'd be expect to simplify again. That takes us back to the fractions, and because it's a ratio, isn't it? Yeah. It means that for every 8 on the map, that there are 1,000,000 in the real world. So maybe I can half this. 4, if that was 1,000,000, that would be 500,000. Let's half it again. 250,000. And half it again. 125,000. So there would be our answer for that scale. Yeah. This is a quite common question that you'll get. Maybe the left hand side would be 1 to start off with, but you're going to get this: simplify the scale. Yeah, measure something, work out the scale, and then simplify at the end, so that you lose the units. And what this means is that for every 1, it could be 1 centimeter, 1 inch, 1 stride, 1 yard, 1 meter, that on the outside, between the real towns, there's 125,000 times more bigger than them. Okay, so what a couple questions that we can look at here. A bit fuzzy, that insect at the top, but just bear with it. Okay, so what we've got, so Drew has made a scale drawing of a bug, and this is not very clear, but this is 1/5 of an inch. Yeah? What's the real life length of the bug? Scale drawing of the bug. Now, if he's made a scale drawing of the bug, how do we know what the scale is. They haven't told us. So the length, each 2 squares is 1/5 of an inch. So we've got 1, 2, 3, 4, 5. 5 times 1/5 of an inch equals 1 inch. 1 inch. Right. Let's have a look. Just check, because it didn't give a scale. Maybe it was on the previous page. Let's have a look. 88, 88, 1 inch. Yeah, so it's not really a scale drawing. It's just he has made a drawing. Yeah, he's just made a drawing of a bug. It's the right scale. The scale is actually 1:1. What a stupid question. Kai is walking in the countryside. He uses a map to find the distance to the nearest village. The distance on the map is 3.4 centimeters. The map has a scale of 1 to 100,000. What's the actual distance? Okay, so we've got 3.4 times 100,000. So that would be 304. Let's do that. Don't get me. 3.4 times 100. 340,000 centimeters. Look, see, there we are, going the other way around. So we've got to make it back into kilometers. So I'm going to do 340,000, and I'm going to divide that by 100, and that will make 3,400. That's a 4. And that would be meters. And then I'm going to divide by 1,000, and that would be 3.4 kilometers. Shabnam is sailing on a lake. The diagram below is a scale drawing of the lake. Okay, jetty, Shabnam. The lake has a real width of 1.5 kilometers, yeah? What's the scale used as a ratio? So we've got to measure this. We've got something to measure with, because depending on your screen size, it's all going to look different. So I'm going to measure that as 6 centimeters. Okay, so the scale used is 6 centimeters to 1.5 kilometers. Oh, as a ratio. So we need to simplify this, don't we? So let's do 6 centimeters. Change that to centimeters by multiplying by 1,000 and then 100. So 1.5 times 1,000 times 100 is 150,000. 150,000 centimeters. I think I can divide that by 6. So I'm going to go 1, just divide both sides by 6. So divide that by 6 is 225,000. Shabnam's position is shown on the diagram. How far is Shabnam from the jetty in meters? So again, I'm going to measure from the jetty to Shabnam, and I'm going to go from there is 2 centimeters, right? Now I'm going to look at this and go, well, right, 2 centimeters. 6 centimeters is 1.5, and that's only 2 centimeters. So can I use this 1 to 25,000? So I've now got my scale as 1 to 250,000. so many zeros in this. So if I go 2 times 250,000 is 500,000 centimeters, and they want it in meters. So divide that 500,000 centimeters. Divide that by 100, which is just knocking off two noughts, is 5,000 meters. Okay, Simon lives in Oaks, doesn't he? Just there's Oaks. He travels by road to visit his friend Tarek in Severn. There. How many miles does he travel? Right, so he's going there, 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 there. So what we need to do there, we know that that is 4 miles. So you need to get your ruler and measure this. So I'm going to go 2. This is 1 centimeter, yeah? From there to there, I've measured that 1 centimeter. So we've got a scale of 1 centimeter is 4 miles. So all I need to do is measure that in centimeters, multiply it by 4, and the job is done. So let's have a look. I'm just measuring on my piece of paper. 2, 3.5, 6.5, 8.5. So all that distance is 8.5 centimeters, all the way from Severn to Oak. So I need 8.5 times 4, 8.5 times 4 equals 34 miles. Ooh, okay. A scale drawing of Lucy, don't forget you pause this and have a go. A scale drawing of Lucy's diagram is shown below. The real dimensions of Lucy's fireplace are 200 by 50 centimeters. What's the scale used in the drawing? Right, so this is 50 and this is 200. So one square is not 1 centimeter, it's 2 squares. I've measured that. 2 squares is 1 centimeter. So this distance here is 4 squares, isn't it? So this is going to be 2 centimeters. And 2 centimeters is 200. So we've got a 2 to 200 scale. That is the same as that. And I'll simplify that and put it 1 to 100. Now Lucy's bought a new table for her dining room. The table is 1.5 meter wide and 2 meters long. So we could also call that 2 to 200, 1 to 200 is 1 square equals 50 centimeters. It's probably easy to understand it that way because that's just that top bit. So we've got a table 1.5 by 2. There should be at least a half a meter, which is 1 square, yeah, all the way around the edge of the table. Use the correct scale, draw on the diagram where Lucy could put the table. So the table is 1.5 meter. Now remember, every square is 50 centimeters. So that is going to be 3 squares. And this is going to be 4 squares. And you've got a gap around it of 1 square. And we can draw it anywhere we like, as long as it's got to be a 3 by 4. So, yeah, 3 by 4, no, let's draw it there. 3 by 4. probably going to bang into the chairs when we get there. So this is 2 meters, this is 2 meters, and this is 1.5 meters. Use the correct scale, draw on the diagram where Lucy could put the table. Okay. Any more? No, there's no more to that. Alright, scales. Quite a tricky one. So, alright, I'll see you in the next one.